Exploring Exoplanets by President Reyes.
Beyond our solar system lies thousands of mysterious worlds. Welcome to the incredible universe of exoplanets.
What are exoplanets? Extrasolar planets or exoplanets are planets that orbit stars outside our solar system. Just 3 decades ago, their existence was unconfirmed. Today, we discovered more than 5,500 confirmed exoplanets, with thousands more candidates.
In January of 1992, astronomers Alexander Wolszczan and Dale Frail made history. They announced the discovery of 2 rocky planets orbiting pulsar, PSR B1257 plus 12 in the constellation Virgo. The discovery changed everything.
How do we find them? Astronomers use clever techniques such as radical velocity transit method, direct imaging, and microlensing. Radial velocity detects a star's subtle wobble. A single star deviated of a planetary system will have its center of gravity located in the center of the star. However, when a planet orbits a star, the center of gravity of the star-planet system becomes offset from the center of the star, causing the star to wobble back and forth from an observer's perspective as both the star and the planet orbit their common center of mass. Subtle changes in the radical line-of-sight velocity of the star can, in principle, be measured to reveal the presence of otherwise invisible planets.
Transit method involves monitoring the brightness of a star over time, and when a planet passes in front of its star host, causes a slight dimming of the star. NASA's Kepler Space Telescope used this method to discover thousands of exoplanets.
Direct
The
imaging
transit method was
captures
also
rare
used to
direct
discover the
pictures.
first exoplanet
Involves
around a
directly
sun-like
capturing
star.
images of the planets blocking out the star's light. A challenge is due to the brightness of stars compared to the planets. Been successful with finding some large young planets that are far away from their host stars.
Gravitational microlensing is when a massive object, like a star with planets, passes in front of a more distant star, magnifying its light due to gravitational fields. This is typically used to discover distant planets that have been employed by various astronomical surveys.
Kepler's legacy. Launched in 2009, NASA's Kepler Space Telescope revolutionized our understanding of the universe. Staring at 150,000 stars, it confirmed over 2,600 exoplanets, providing that planets are more common than stars. TESS Transiting Exoplanet Survey Satellite. Launched in 2018, TESS focuses on surveying the brightest stars near Earth for transiting planets. James Webb Space Telescope, JWST, launched in December 2021. JWST has advanced our ability to study planet atmospheres and potentially detect biosignatures. To date, more than 5,500 exoplanets have been discovered and are considered confirmed out of the billions in our galaxy alone. There are thousands of other candidate exoplanet detections that require further observations in order to stay for sure whether or not the exoplanet is real.
Kepler in K2 shows our galaxy contains billions of hidden exoplanets, many of which could be promising for life. They also prove that our night sky is filled with more planets than skies. Kepler was supposed to monitor about 100,000 main sequence stars over a period of 3.5 years, but during the first 6 weeks of its operation, it discovered 5 exoplanets, Kepler 4b, 5b, 6b, 7b, and 8b. K2 still hunted for planets, but it scanned larger regions of the sky than before, along the ecliptic plane. It lasted as long as the first mission, but it surveyed almost more than 500,000 stars. As mentioned before, TESS launched in 2018 and is continuing Kepler's legacy. Focusing on bright nearby stars, meanwhile, the James Webb Space Telescope peers into exoplanet atmospheres, searching for signs of life.
HD 189733b and WASP 39b. On HD 189733b, it likely rains glass sideways at 5,400 miles per hour. WASP 39b revealed a detailed chemical atmosphere showing signs of sulfur dioxide, photochemistry, and clouds thanks to James Webb. WASP 39 Bocaprius Kepler Space Telescope identified the most detailed analysis of an exoplanet's atmosphere ever with this exoplanet. Identifying sulfur dioxide in an exoplanet atmosphere, also observing photochemistry at work on an exoplanet, reactions triggered by starlight. While Webb and other space telescopes, including NASA's Hubble and Spitzer, previously had revealed isolated ingredients of this boiling planet's atmosphere, with the new reading from Webb provide a full menu of atoms, molecules, and even signs of active chemistry in clouds. Observations of the planet WASP 39b show fingerprints of atoms and molecules as well as signs of active chemistry and clouds.
We now know planets are not rare at all. They're everywhere. Kepler showed our night sky holds more planets than stars, and many may be in habitable zones. In just one generation, we've answered a question once thought unanswerable. Are there other worlds out there? Yes, thousands, and we're only just beginning to explore them.
And these are our references.